All right, what's going on, everybody? Today we're going to be doing a linked list cycle. It's another list problem. So we're just given the head of a linked list, and they want us to determine if the list has a cycle in it. So what does that mean? Basically, if there was no cycle, right, we'd eventually get to a node which points to null. If there is a cycle, each of these nodes can only point to one thing, right? So eventually, if there is a cycle, there's going to be a node that points back to a previous node in the list. And that, by definition, is a cycle. They want us to return true in that case, and then false if there is no cycle. So one thing that I'm going to note here is they ask as a follow-up, can you solve it using big O of 1 or constant memory? So with that in mind, we're just going to be focusing on constant memory solutions here. So let's just get straight into the constant memory linear solution here. So we know if we have constant memory, we can't use like a hash map or a set or anything like that, right? Because we need constant memory. We need a fixed amount of memory. So uh, with our solution, we're just going to use a fast and a slow pointer, right? So just 2 pointers, regardless of the size of the list, and we'll be able to determine if this list has a cycle uh, with every case with this algorithm. So let's just go ahead and uh, just step through the algorithm if there were a cycle. So let's look at this example. And we're going to have a slow pointer. It's going to point to head. We'll have a fast pointer. It'll also point it to head at first. So, right, fast pointing to head. Slow is also pointing to head. And basically, we're going to just iterate while our fast pointer is pointing to a node and while it's next while our fast pointer is pointing to a list node, and while the next list node that it's pointing to is also a list node, right? So this needs to have a list node. This needs to have a list node. Well, that's those two things are true. We'll just keep looping. So now that we have that out of the way, let's go through an iteration. So for our first iteration, we're going to move our fast pointer by 2 nodes, right? So next. This will be where our fast pointer is, and then we're going to move our slow pointer just by 1 node. So next, and that'll be the where these pointers are pointing to after one iteration. So, and we're just basically looking for this case. So while the fast pointer is equal to the slow pointer. And what this means is basically the fast pointer and the slow pointer are pointing to the same node. That's what this means. So, and we know obviously if there was no loop here, the fast pointer would never intersect with the slow pointer, right? The slow pointer would always be behind it. It would never catch up, right? So basically, let's keep looping through this to kind of see what would happen here. So if there is a cycle. So move the fast pointer by 2, so it would be here, right? Next, and then our slow pointer just by 1, it would be there. So let's go ahead and erase that and that, and then let's iterate again. So fast pointer by 2, 1, 2, 2 nodes forward, slow pointer 1 node forward, and we can already see that these are pointing to the same node. So the case where these are equal would be true. We can return true when we get this in some iteration of our loop, right? So we know there's a cycle there, right? And this loop, you might be wondering, like, how long does it take for these pointers to intersect? Well, the thing is these are always going to intersect if there's a cycle. Like, it doesn't matter if the cycle was like this, or if it was like just one. Like, it doesn't not matter what the cycle are. These are going to catch up with each other at some point with this algorithm. You can check that with like a bunch of different test cases to prove this to yourself. Um, but these are always gonna intersect when there's a cycle. So let's look at the case where there's no loop or no cycle, just to kind of prove that this also, effectively determines when there is no cycle. So like if this was just pointing to null, and like we don't even really need to step through this, like you should be able to see, right? So slow is pointing to head, fast pointing to head. Like if fast is always moving forward by 2, and we reach the point where fast next or fast is null, right? So like we would ultimately, well, it'd be there. That would just be 2 iterations. So slow would be here, right? Like one if fast is 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 null or fast next is null, like we know we reached the end of the loop, like without um detecting a cycle. So yeah, that's pretty much it for the algorithm. It should be pretty straightforward. So again, this is going to be linear time with respect to the size of the list, right? And constant space because we're only using these 2 pointers. So let's get into that code. So basically, we're going to need two list nodes, right? One for the fast pointer and one for the slow pointer. So say list node star slow, and that'll be head at first. And I'm just going to recycle the head pointer to act as our fast pointer so we don't need to allocate space for another pointer here. So we'll just treat the head pointer like the fast pointer, and we're just going to loop while the fast pointer is pointing to a node, and whatever its next node is also pointing to a node, right? So both of those are not null pointer. And we're just going to move the slow pointer uh, down one node with each iteration by assigning slow to slow next. And then we're going to move the fast pointer down two nodes by assigning head to head next next. So like that. And then we're basically going to check, right, at each iteration is our head pointer equal to our, or is our fast pointer equal to our slow pointer? And if that is true, we know they're pointing to the same node, and that would never be possible if there was no cycle. So we know at that point there is a cycle, right? So we're going to return true. Now, on the other hand, if we get through all of this and our head becomes null or head next becomes null, we know that we've reached like the end of the list. So, and that would never happen if there was a cycle, right? So we can return false at that point because we know for sure there's no cycle there. So that's pretty much it for the code. Pretty concise. So let's go ahead and run this. And as you can see, it's a pretty efficient solution. I've seen this solution beat 90% for both space and memory. So hopefully this video helped you understand this problem. If it did, please leave a like and subscribe, and I'll see you guys in the next piece.